So now we're moving on to 2.4. This is writing proofs, okay? This is the part where what you normally think or do on your calculator, here is where you need to start writing everything down. Okay, so we've got a fair amount of new vocabulary that you may know some of them, but not all of them. But let's have a look at the basic ones to start off with. Is a postulate or axiom. That's a statement that's accepted as true without any proofs. Okay, so let's have a look at 2.1, and you don't have to remember the numbers, you just have to remember how to apply them. Okay, through any 2 points there is exactly one line. That's what you were doing in 1.1. Okay, through any 3 points that are non-collinear there is exactly one plane. Remember from 1.1 you were writing 3 letters for a plane, etc. And then we'll go through the list. Okay, so take your time, work out, go through the list if there's anything that you need to make notes of. But this is one of these things where, like I say to you, it might be worthwhile cropping and taking with you into the question pages. Alright, so going from that table that you should have made notes on, as you go into the diagrams, things like, what will you find? So, for instance, in A it said the lines N and P intersect at point D. All right, well that, according to the table you just read, is postulate 2.6, where when 2 lines intersect, they intersect at only 1 point. Okay, A, B and D form a plane. Okay, so A, B and D are non-collinear, so therefore it's just a plane, it's exactly a plane, and that's postulate 2.2. So at the moment all we're doing is getting used to what are the postulates. Okay, so let's have a look at some of these questions. So let's have a look at number 1. All right, number 1, planes P and Q intersect at line R. All right, so which is that true? Yes, it's true, so it's true. So which theorem do we need? Well, that is, if we're going back to that statement, that table of values, that's 2.7, because where 2 planes intersect, they intersect at a line. Okay, let's have a look at another one. So, for instance, let's take number 5, all right? So, number 5, line N, lines on plane Q. All right, so is that true? Yes, it is, so that's also true from the diagram. Okay, and which postulate does that? Well, that's 2.5, okay? And 2.5 says that if 2 points lie on a plane, then the entire line containing those points also lie on that plane. Okay, so here's where it starts getting a little bit tricky. Determine whether each statement is always, sometimes, or never true, and explain your reasoning. Okay, so there's several things you have to do here. First and foremost, you have to work out whether it always happens, if it sometimes happens, or it never happens. And if it always or sometimes, you then need to come up with the postulate that comes up with that. Again, going back to that table of values. Okay, so A, it says if 2 coplanar lines intersect, then the point of intersection lies in the same plane as the 2 lines. Well, that is always, and postulate 2.5 is the one that gives you the answer to that one. Okay, on B, 4 lines are non-collinear. Well, that obviously has to be sometimes, depending on the diagram. Okay, so 4 points, you only need in 2.3 2 points to lie on to make a line. So this means it could be 2 or more. All right, so that's got to be sometimes. So let's have a look at these. All right, if the plane contains a line and a line contains a point, then the plane contains the point. Okay, is that always, sometimes, or never? Well, go back to that table of values, and if you look at that table of values, okay, 2.5 fits that one. So we know that 2.5 fits that one. Okay, but now we've got to make the decision, is it always, sometimes, or never? Well, that is always. Okay, so here's some of the properties of real numbers. You would have remembered this from Algebra 1. Again, start taking it through with you. And these are all the properties of addition, subtraction, multiplication, division. You've done all that before. The reflective property is a new one that you may not have done in Algebra 1. okay, but symmetric and transitive you would have used, and then also substitution and especially the distributive one. Those apart from maybe the reflective you would have used in Algebra 1, okay? But again, look at how they've done the notation, or used letters I should say. If A equals B, then A plus B equals B plus C, etc. Alright, so start looking at not only the properties but also the notation that goes with it. And again, this is one of these things that as you're answering the questions, it's best if you crop it, take it with you, so rather than flip back pages, you've got it there with you. Alright, so now we're moving on to example 3. Now we're writing algebraic flow proofs, okay? In other words, what you do normally in column ways, you have to go and put it in a flow chart, okay? You always start with what you've been given. In this case, you've been given that y plus 2 all divided by 3 equals 3. So from that, you've got to prove that y equals 7. So in other words, you're going to be doing the actual algebra, but you've got to write it down in a flow chart. So you always start with what you've been given. That's the first. Okay, and then obviously what you need to find is always last. So now all you've got to do is fit in the steps, and it might be like this one, there's 2 steps, sometimes there may only be 1, but then there also could be many, so work it through. All right, well, the first thing is you always get rid of fractions, so we need to get rid of the 3, and we get rid of the 3 by multiplying it both sides. So there's where your second line is. And again, look, you have to write what you've been given or what you need to do. So what you do in your head or on your calculator, you now need to start writing down. Okay, and then once you've multiplied through by 3, you're substituting in, so your 3 times 3 will disappear, which will give you 9, so you're then substituting in. So there's your third section, but again, you have to write down what you've done. All right, and then finally, you are subtracting 2 from both sides to come up with your answer. Okay, so everything that you normally do in your head or on your calculator, you need to write down, and you need to say what you've done. All right, so this is the way that you would normally have it, either in a quiz or a test or something like that, okay, where you've been given part of it and certain sections of it, you've got to fill in the rest. Okay, so what have you got to do? So let's start with what you've been given. So here's your given, and as you can see, it's been replicated here, so you know that this guy here has to be given. All right, and what happens to the 5x minus 12 equals 8 from this one to this one? What do you do? Okay, well, as you can see, here's what you've been doing. So this is addition. All right, you should write addition, property of equity, but addition is sufficient. That's all we're interested in. Okay, and then what we've done is actually got rid of that, and we've collected that together. So in theory, we are doing substitution at this point here. So if 5x equals 12, we've done the division. So we now know that x equals 4, and that's the proof that we needed to do. So do what you normally do in your head or on your calculator down on paper, and also write or show what you've done. Okay, so now we're writing a geometric flow proof. In other words, as you can see from the diagram, there is no algebra, there's no numbers, it's just purely and simply letters. So when you get questions like this, you have to read the statement and the questions before you actually start. So let's have a look at what we've been given. All right, we've been told right in the statement that Q is the midpoint of PR. So in other words, we know that that has to be the middle. Okay, so straight away we know that PQ and QR must be congruent. So these are the things that we're looking for in a diagram. All right, so what we're given, we know what we've been given that, so that must be our first, remember? And we know we need to prove this, so there's our last. Okay, so now all we've got to do is fit in. Well, the only thing we've talked about so far in the statement is the fact that it's a midpoint. So it's the definition of a midpoint. And like I said to you right at the beginning when we did these little notations, that PQ and QR must be congruent. Okay, so that's the definition of congruence, or you can just write congruent, that will be sufficient. Okay. All right, so now we're getting on to the point that students really dislike. This is writing a paragraph proof. Okay, in the first example, you did the algebra part of it and writing that down. The second part, you did a flow chart. Now you're actually going to be writing what you have to do. So basically, it's a story just like you would do in English, where you write out exactly what you've done. All right, so let's have a look at what you've got. Right, first and foremost, always go with what you've been given. All right, you've been told that C is between A and B. All right. And you are told that AC and CB are congruent. Okay, this little notation means that they're congruent. So let's have a look at what you've got. Here's your diagram, and it's basically the same as the one that we had in the previous example. All right, so we do now know that C is the midpoint. So you can follow through basically what you did in the previous example, but this time, as you can see, you have to write everything down. Okay, so the proof is if C is between points A and B, then the definition of betweenness is that they are collinear. And again, you can use the fact of addition, properties of addition. Okay, then the fact that they are congruent, and then you can work out that C must be the midpoint of AB, etc. All right, so basically what you wrote down in a flowchart last time, you're putting it in a paragraph proof this time. Okay, so let's have a look at how we would do 14, and then obviously we could write it as a paragraph, but let's start off with, okay, what we've been told. First and foremost, we've been given a diagram. Okay, we've been told that JK is 15 and KL is 3y minus 9, so we've got a bit of algebra. Let's have a look at what we've been given. We've been given that JK is congruent to KL. So in other words, we can make this assumption that this guy is congruent to that. So now let's start writing it down. So we now know that JK, all right, is congruent to KL. That's given. All right, so we know that that's given. In theory, it should be in a little box. All right. The definition of congruence, in theory, you should be writing JK is congruent to KL. That's congruence. All right, so what we're going to do next, we're going to replace the letters with the what we've been given. All right, so we know that 3y minus 9 equals 15, and we're now substituting in. So we've substituted in the algebraic expression for the letters, or the letters for the algebra. So this is substitution. Okay, and I'm going to come around here, I'm afraid I'm running out of space. All right, so what do we need to do first? Well, we need to add 9 to both sides. So I'm going to skip that. So that's 3y equals, lost it, 24. All right, so that's substitution. No, that's addition, I should say. Okay, because we added 9 to both sides. All right, then what we're going to do, from there we're going to divide, because we need to divide that. So we need to do 3y divided by 3 equals 24 divided by 3. There's division. All right, then we're going to come up with our answer, the fact that 8y equals 8. Okay, and again we're substituting in. And then finally we're going to come back to the fact that, in fact, that's good enough. I've gone too far, but yeah. So y equals 8, which is all we need to do here. All right, so back up here, that's what we had to prove. We've proved it, so it's substitution, but it's also our proof. Okay, so everything that I've done there, I could then write in a paragraph for number 15.